Even today, we are going to focus on VXLAN EVPN. It's a continuation of the previous class. In the previous class, we saw VXLAN EVPN with multicast as the replication and then BGP as the replication protocol. So BGP is not only the reachable protocol, we also want to use BGP as a control plane of VXLAN, meaning we would like to replicate the MAC address and the VTAP address information of all the edge devices using BGP. That is what we call it as ingress replication. Ingress replication. For all the bomb traffics, ingress replication will be responsible. BGP will do that. Whereas in multicast replication, it's always the multicast, whether it is unknown unicast or broadcast or multicast, it's going to be multicast only. Now, what is the difference between the previous class and this class? In this class, we did not, the previous class, we did not have spine. In this class, we have spine. Why do we need spine? You see, in the previous class, when you don't have spine, you got only one link between these two. And then if you want more links, then you may need a layer 2 links and they need to form a bundle, which may not be possible for you. So when you have spine and connect all the leaf to all the spine and no leaf to leaf connection, no spine to spine connection, when you connect all the leaf to spine and all the spine to leaf, the advantage is ECMP, equal cost multipathing. Anywhere to anywhere, if you see, from any VTAP to any VTAP, from any leaf to any leaf you see, you will have 2 hops, only 2 hops. For example, I have only 2 leaves. Between these 2 leaves, I have 2 paths, and both the paths have got 2 hops, which means it's an equal cost path. Now, if your underlying protocol is OSPF or ISIS, it is going to provide you both the paths for you to have an overlay, VXLAN. So VXLAN is going to have double the bandwidth, double amount of bandwidth. When you have another spine and connect both the leaf, now you got 3 paths to reach from one leaf to another. So earlier it was 2 gig, 1 plus 1, 2 gig. Now you add another spine, you got 1 more gig added for your traffic. It's highly scalable without disturbing the existing traffic flow. You will be able to expand your network when you have leaf and spine architecture. In a data center or within an organization, this is possible. May not be easy to do when you are doing between customers using a public service provider network. But if we are doing within an organization, you see that cloud picture. It's within one cloud. Whereas in the previous class, the picture was different. The previous class, the cloud was in between 2 edge. It is not same. This is edge of one organization, this is edge of another organization. In between you got cloud. So when you have something like this leaf and spine architecture, you got a lot of advantage. You can increase the size of your topology without disturbing the existing one. You can have more speed just by increasing the spine. You can have more connecting devices just by adding leaves. We call this as leaf and spine architecture or clause architecture. Clause is the name of the person who proposed this architecture. This is not something new. This is there for many years, but it was not famous. And it has gained importance now in recent 5 years, I can say. Close architecture, leaf and spine architecture. So if you want to connect more hosts, if there is no enough port for you, then you connect another leaf and you will get more ports. Easy to expand. Right, so this is one reason why we are today learning VXLAN with spine. Your VXLAN will get more bandwidth now when your underlay has got more paths. Our VPN tunnel is actually going to be between this. But the tunnel is going to now use double the amount of bandwidth because the tunnel is established using the underlay which has got 2 gig links now, not just one link. If I have another switch as a spine, then I'm going to have 3 gig underlay. So the tunnel speed is going to be increased. Fine. What is needed to achieve this? As you know, we need a spine switch. What else? We need a switch that will support multicasting if you are going for multicast replication. Ingress replication, you need BGP. On the spine, there is no big thing we do. Okay, one more thing is, because you do multicasting, the rendezvous point will be spines. Rendezvous will be spines. If rendezvous is spine, I have 2 spines. Both will be rendezvous. Meaning, whatever this rendezvous point learned need to be also seen in this rendezvous point. Whatever is learned on this rendezvous point need to be synchronized with this rendezvous point. For that, what we do is we use one single IP address as a rendezvous point on both the routers. You see, 172.16.255.255, 172.16.255.255. So we are going to use one single address on both, and we will identify these 2 boxes with another loopback address. With that ID, we use a protocol called MSDP, Multicast Source Discovery Protocol, to sync between these RPs. To sync between this rendezvous point, we are going to use another loopback on this switches, which will have a unique IP address. Say for example, 172.16.221 will peer with 172.16.255.2. 2551 and 2551 will peer, MSDP peer with 2552. MSDP peer of switch 2 is switch 1, which is 2551. We call that as MSDP, Multicast Source Discovery Protocol, so that 2 rendezvous point will get sync. Rendezvous point we saw earlier, both the source and the group member meets there. Both the source and the group member learn each other. Group member will learn about the source will learn about group using the rendezvous point, the meeting point. So the meeting point need to be synchronized. It needs to be one. But in our case, because we got multiple spines, we want all of them to be a rendezvous point. At the same time, we want all to be synchronized as one. For that, we use MSDP. I repeat again. This MSTP story will not be there for ingress replication, because in ingress replication you are not going to use rendezvous point. We are not going to use multicast. We are going to use BGP to replicate routes. Only in the multicast replication you will have extra fittings like MSDP. All other things are same. What you learned in the previous class and what you are going to do today is same. You see, earlier the leaf was forming IBGP neighbor with another leaf. This time, no leaf to leaf. This time, leaf will form IBGP with spine. So, you see, the ingress replication has got only BGP. So, you don't need to worry about this rendezvous point, this MSDP protocol. Only on this multicast replication, multicast needs these things. Apart from this PIM sparse mode, you need to have two RPs with same IP address on the spine. Earlier, our RP was the leaf itself, but now RP is the spine because it's the middle device, right? So we make our spine as RP as well as the BGP's route reflector because it's a middle guy. Secondly, to sync between RPs, we need MSDP. These are all multicast needs, not for ingress replication. So keeping all these things in your mind, let us go through the configuration now. You see, first of all, I'm going to show you the leaf 1 configuration. Where is leaf 1? See the picture? Leaf 1 is this configuration. L2 VPN, EVPN. See, the multicasting is enabled. This need to be enabled. This will be by default enabled. This need to be enabled. And then L2 VPN, EVPN is the command that enables EVPN. And then replication type static is a common command that is for both ingress as well as multicast. And then this command, what it says is we will define what will replicate, whether multicast will replicate or BGP will replicate. We will mention it. That's the meaning of it. We'll mention it. That is the meaning of this. We'll statically mention it. And then we give a router ID for this EVPN to use. And then this is the command that enables the EVPN instance for VLAN base. And we are saying this EVPN should use VXLAN encapsulations to form the tunnel. It's only based on the VXLAN VNI IDs. The traffic need to be encapsulated. Now this is not a VLAN number, this is just an instant ID to identify the EVPN instance. Next is we create a VLAN. This is the VLAN to which the host is going to be connected. And we say this VLAN traffic will be passed inside the VNI 10101. Any number you can give. Here they are using 10101 as the VNI ID. So we are just transferring the VLAN traffic into VXLAN. These are all needed for router ID. Say for example, EVPN is using 254.3. 254.3. And if you see multicasting, it will use loopback 2, this address. Okay, there is no loopback 2. Then the multicasting will use this one. Or the same address, doesn't matter. Let's see what is configured. Now we got two loopback interface. One for multicasting, you see the sparse mode is enabled. One for just, some other identification they are going to use. We'll come to know in the later session, later page. Okay, now we need to run PIM as well as the OSPF as usual. These are all no difference between the previous one that you learned and this one. And this is the interface that is facing the spine. How many interfaces are facing the spine now? There are two interfaces. One of you have not muted your mic, kindly mute. There are two interfaces that is facing spine. One is gig 1/0, another one is gig 1/2. So there are two interfaces, gig 1/1/0 and 1/1/2. These two interfaces should run OSPF. Sorry. And that's what you're going to see here. Both gig 1/1/0 with 13.1 and 23.3, they both are running OSPF, and also they both run sparse mode. Next, this is the interface that faces the host. A host interface belongs to VLAN 101. Next is we got the tunnel interface. Tunnel is going to use loopback 1 as the router ID, same like what EVPN uses. Of course, this is going to be a EVPN tunnel interface, right? So you should use the same loopback 1. See, there in top also you have loopback 1's IP address under EVPN. Same thing. And then the reachability protocol to negotiate tunnel from this tunnel interface to the remote, I'm going to use BGP to have reachability. And for unknown traffics like bump traffics, I want to replicate via multicast, and this is the multicast group. This is the multicast group address. And this address will be same on all the leaves. And these configurations are not going to be there on spine. This is only for those tunnel endpoint devices. Next is we got OSPF followed by BGP. Now, the difference here in this lab and the previous lab is, in this lab we will have two IBGP neighbors. In the previous lab we had only one leaf. Now we are not forming neighbor with leaf, we are forming neighbor with spine. This is loopback 0 interface IP address. This is not loopback 1 interface IP. This is loopback 0 interface IP. So we got two loopbacks, right? 0 and 1. We are using loopback 0 to form IBGP, and we are using loopback 1 for eBGP and VNI interface, NVI interface. Loopback 0 and loopback 1. Loopback 0 is this one. So you see 2551 and 2552, 2551 and 2552, they are the loopback address of this device, these two devices. So we are forming neighbor using the loopback. So we need to use the command update source loopback 0. And we need to activate EVPN. We need to activate EVPN. So we activate these two under EVPN, and then we define RP address. This is the layer. This is one of the loopback in spine. Loopback 2. Spine have got three loopbacks: loopback 0, loopback 1, and loopback 2. Loopback 0, loopback 1, and loopback 2. This is spine's loopback 2 interface address. This is going to be RP's address. In the picture, it is not clear. So I have written here in my document in words, means with hand, 2525. This is the RP's address. And you see, it's the same address on both the spine. So when you say RP address, this, you mean two spines here, because both the spines have got the same address, whichever is easy to reach. That will be used as the RP. And the RPs are synchronized using MSDP. Yep. So this is about leaf 1. Leaf 2, there is no much difference. Even BGP configuration is going to be same. Only the difference will be the local loopback interface address. All right. There is no other difference. Even BGP configuration is same. You are forming adjacency only with the spine. And then comes the spine configuration. Spine configuration, you will not see any EVPN related. You will simply see BGP and multicasting. Multicasting with RP and MSDP. You see, I told you, the third loopback interface. This is the address that we use as an RP. That you will see in the last line here in this configuration. If you go down, you run OSPF, you run PIM, and now you are forming IBGP with 2 leaves and 1 spine. Spine will form neighbor with the other spine as well as the leaf. You see 255.1. I'm in what? I'm in spine 1. I'm in spine 1. It will form neighbor with 255.2, which you see here. And then it will also form neighbor with 255.3, which is leaf 1, and then 255.4. And you need to activate. This is the only EVPN configuration you will have, because BGP is the control plane. There is no other EVPN configurations as you saw, like encapsulation or type VPN, L2 VPN type, nothing like that. Only for under BGP you need to activate the members. And then this is the RP address. As usual, this is the same command what you saw in the previous labs. And this is the new thing that you have. IP MSDP peer address. This is the loopback 1 IP address of spine 2. You want to see? You see? Loopback 1 address of spine 2 is given as the MSDP peer. With that only it negotiates and connects. You see, from source loopback 0, it's negotiating. BGP remote AS is this. That's all. These things will come automatically. Period. On spine 2 also you will do the similar thing. Only the change will be the neighbor statement. Here you got a neighbor address 1, 3 and 4. 3 and 4 are 2 leaves. That's all. The multicast replication using spine. Any question? You will have the comfortness only if you go through yourself. Otherwise, you don't have question, but still you don't feel confident. You don't have question. At the same time, you don't have confidence because you need to go through by yourself.
No, the problem is to do configuration. When you do the configuration, we face some problem. Then there we have.
See, you should not have configuration issues if you understand and do. The commands, if you want to know, you need to refer the document. Commands will not come from heaven straight to your brain. Of course, you have to go through the document. But the logic, if you understand, see, before I start the class, I told you what all will be extra fittings. MSDP, I told. And BGP, there will be more adjacent neighbors. And I said there will be a route reflector. and there will be two RRs. So my mind is prepared to see all these things when I go through the commands, and I can see those commands, and I'm satisfied. So when you know the logic, you will know what all need to be seen in configuration. And when you know how to configure them by using command, then you are successful. So things are like, first knowing things in depth. That's why, I always say there is nothing called troubleshooting. It's a funny language. Troubleshooting is a funny word. Why in first place put trouble? Because you do not know properly. That's why you created trouble. If you know things proper, you would have configured correctly. There won't be a trouble. Why someone need to come and troubleshoot? That's not really correct. Doing things proper will not have trouble, and there is no need to troubleshoot. So first of all, you should know what all takes for VXLAN to do multicast replication. After that, you need to expect those things in the configuration guide. And when you see them, then you understand the commands to configure. And when you put those commands, why do you face trouble? See, troubles like this command is not supported. Those troubles are accepted because that's not your fault. That's not your fault because the iOS is not supporting. It's not your fault. You need to simply switch the iOS or the EOS or XOS or XR, or whatever the next is. You need to change the version or the box, but you know the concept. You know how to configure, but the device is not supporting. That's not your fault again. So know the truth, and truth shall deliver you. That's what Bible says. Know the truth. In everything, it will match. If you know the truth in anything, any whatever the department may be, if you know the truth will set you free. Truth will set you free from trouble. You won't have trouble. There won't be a troubleshooting. What do you say, Ko?
Hello?
Do you agree with me?
Yeah.
So, learn the logic behind VXLAN first, and then see to achieve that logic what all protocol it takes. After that, see the configuration side of the protocol. You are done. Okay. So we got one more. Let's do one more. And this is the last topic of EVPN. Ingress replication. See, everything is same except that BGP push. If you go down here in the ingress replication, we use the additional line here on the leaf saying replication type ingress. See, this is under L2 EVPN is a replication type static. This is under instance. Under instance, we did not say this line in the multicast replication. In the multicast replication, we did not say why, because that is the default replication type under an instance. Under an instance, that's the default. But here, we should give this command because it's BGP. We do not want the default multicast replication. Next, these configurations are well known for you. Yeah, here we gave actually a multicast address earlier under NVE interface. Now you are going to say ingress replication. Again, this is all not new to you. Yesterday you saw these things in the class. And now here, same like what you saw in the previous multicast replication, same configuration, two spines as a neighbor. All right, activation. That's all. See, This is very easy than the previous multicast replication. There is no sparse mode, there is no RP, there is no MSDB. See, another leaf, similar configuration. Only thing is replication type. And then here, ingress replication. Sorry. So that's it. Now let's go to the spine. Spine, there is no big difference. It is easy. Only the BGP configuration you will see with EVPN under BGP, 3 neighbors. Same like what you did. That's all. Nothing more. Spine 2. So I request you to kindly go through this document. I'm sending you this document. Go through this. If you can take a printout and compare pages keeping next to next, it will be much better. Master